Types of graphs. Today we're going to be working on different types of graphs. We've already met linear graphs and quadratic graphs. Today I'm going to introduce you to some others. And our learning objective is going to be able to identify different type of graphs. Here we've got an example of an equation, and the different parts of the equation are labeled. The green, the number in front of the variable, is called the coefficient. The number is called the variable. It could be an x, it could be a y, it could be a z. In this instance it's an x. And the numbers that stand on their own are called constants. These are key words that you need to know, recognize and remember. Copy them into your book. Pause the video and quickly make a little note. We're going to be focusing on four main graphs today. On linear, quadratic, cubic and reciprocal graphs. You have met two of them before, so the only new ones really are cubic and reciprocal graphs. The slide that you can see in front of you is the first part of the worksheet that is included in class charts for you to finish for your home learning. So if you are not printing them off, then please make notes in your book, and as you work through the different pieces, put in, make notes. For example, with the linear, write down example of a linear graph and other key points that will help you identify these graphs later on. So, as I said, we have already met straight line graphs, which take the general form of y equals mx plus c. In this meme, it says plus b, and that is American, but it's the same as plus c, it's just a constant. While y equals mx plus c is a general equation of all linear graphs, y equals 2x plus 4 is a specific equation of a linear graph. The highest power of the variable in a linear equation is going to be 1. It isn't customary for us to include that one, but it is always implied. Here is the graph of y equals 2x plus 4. We can see that we've gone 2 across and 4 up, so that's 4 divided by 2, and that gives us the gradient of 2. We can also see that the graph cuts the y-axis at 4. Here is an example of how linear graphs are used in real life. We've got a distance time graph. If you think about it, when we're working out the gradient of a straight line graph, we are dividing the change in y by the change in x. So in this case, it would be distance divided by time, which would in fact give us speed. So the gradient of a distance time graph is speed. If our m value is negative, it is going to give us a negative gradient. A quadratic graph is produced when you have an equation of the form y equals ax squared plus bx plus c, where b and c can be 0, but a cannot be 0. Have a little think, see if you can figure out why a cannot be 0, and send me an email if you think you have figured it out. Now, all quadratic graphs have a line of symmetry. Positive quadratic graphs, where a is bigger than 0, so where the a value is positive, are U-shaped and have a turning point at the bottom of the curve. A negative quadratic graph, where a is smaller than 0, so where a is negative, you're going to have an upside down U shape and have a turning point at the top of the curve. Y equals ax squared plus bx plus c, as I said before, is the general equation of a quadratic graph. The highest power of our variable is going to be squared, and that squared is what's going to produce this lovely curved shape. For every one y value that you have, you're going to have 2 x values. Here, the horns of the cow produce a quadratic curve. cubic graphs. A cubic equation contains only terms up to and including x to the power of 3 or x cubed. Here are a couple of examples of cubic equations. As you can see, the highest power in y equals x cubed is the 3. In this one down here, y equals x cubed plus x squared plus x plus 3 is another equation of a cubic graph, and its highest power again is 3. Y equals x cubed plus 4, again our highest power is the 3. These equations create a S shape. Okay, get to 5s, you would be expected to be able to plot a cubic graph. You do this exactly the same way as you would do with a straight line graph or with a quadratic graph by using a table of values. In this case, you do need more than 3 values, which you would only need if you were doing a straight line graph, because you need enough points to plot that nice S shape. So it wouldn't be any different. You would be taking the x values that you were given and you would substitute them into the equation that you were given. Here y equals x cubed plus 5. So in the first point, when x equals minus 2, substituting minus 2 into the equation instead of the x, you would get minus 2 times minus 2 times minus 2 plus 5. Now when you are multiplying 3 negative numbers, you will land up having a negative answer, because you've got negative times a negative is a positive, and a positive times a negative is a negative. So you will land up with negative 8 plus 5, which is going to give you minus 3. You would do that for all the points that you are given, and after you have plotted them, these would be your answers, and you would land up with this sort of S shape. A cubic graph has 2 turning points. I have circled them here in blue. Those are our turning points. That's when the graph changes direction. The yellow crosses are our x-intercepts. They're also called roots. In the quadratic graph, we would only have one turning point over there, and we would have 2 roots. Now, if you have a look at the quadratic graph that has 2 roots, and you know that the highest power of our variable is going to be squared, or 2, the 2 roots, okay, they coincide with that. And with our cubic graph, where the highest power of our variable is 3, we have 3 roots. And here's an interesting cow representing our cubic graph with its horns. Reciprocal graphs. A graph of the form y equals 1 divided by x is known as a reciprocal graph, and if drawn, looks like the one you can see over here. Those blue lines are the graph. So y equals 1 over x. If we were going to plot it, and you're not going to be asked to plot it, you just need to know what it looks like. So you need to be able to identify it. But if, for example, you were going to be plotting it, and let's say that you take the x values that you have been given in a table of values and you substituted them instead of x, so start with minus 5, you will end up with a fraction. So y will equals negative 1/5, and as a decimal that would be a negative 0.2. Putting in negative 4 instead of the x, we would land up with a negative quarter, which would give us negative 0.25. Now, if we plotted that, we would get this little curve. And if we work up through the x values, eventually we would get to 0. And y equals 1 divided by 0 is going to give us no value. It is undefined. In fact, if you've got an iPhone and you ask Siri to divide 1 by 0, often it gives you quite an amusing answer. So the value at x equals 0 is undefined, and this is why the graph never touches the y or the x-axis. It gets close to it, but it never actually touches. So there you can see the y-axis and the x-axis, and the graphs never touch. So those vertical lines that the graph does not touch, that the reciprocal graph will never touch, are called asymptotes. You don't need to know that word for now, but you will probably learn it next year. So it is here just for interest's sake. Okay, so this concludes our work on graphs. What you need to do now is answer the questions on the worksheet. There are 2 pages. If you're going to be printing the last 2 pages, it's a 4-page document, are answers. You don't need to print those, you can mark those off the screen. If you do not have a printer, just write the answers into your books as you have been doing. Take a photo of your work and submit it on class charts. A lot of you have been doing that. It is amazing. I love that because it also means that I can't miss a submission. You guys have been working really hard, and I want class charts to be able to reflect that.